Bismillahirrahmanirrahim. Assalamualaikum. Good morning. Good afternoon. Today, I will be presenting about quantum computing. My name is Ahmad Afif Irfan bin Suhaiti, and this presentation is for our ITC2113 Digital Technology and Society course. Okay, so what is quantum computing? Quantum computing is a new type of computing that works very differently from the computers we use every day. The idea for quantum computers started in the early 1980s by a physicist named Richard Feynman. He pointed out that normal computers could never properly simulate how atoms behave. Let me explain why this matters. Atoms and molecules follow the rules of quantum physics, quantum mechanics, which are very strange and complicated. Feynman suggests that to understand quantum systems, we might need computers built from quantum parts themselves. And that's how the idea of quantum computing was born. So, how does it work? Now, let me explain how quantum computer work. This is the most important part to understand. Normal computers use something called as bits. A bit can only be either 0 or 1. Everything you do on your phone or laptop, such as watching videos, writing documents, or browsing the internet, is built from millions of these simple zeros and ones. But quantum computers use something different called as qubits, short for quantum bits. Unlike normal bits, qubits can be 0, 1, or both of them at the same time. This property is called as superposition. Think of it like a spinning coin. It's spinning, but it's not really head or tail. It's both possible at the same time. Only when you catch it does it become one or the other. A qubit works in the same way as that. Quantum computers also use something called entanglement. This is when two qubits become connected in a way that measuring one instantly tells you something about the other, even if they are far apart. Einstein actually called this as spooky action at a distance because it seemed impossible in the logic. By using superposition and entanglement together, quantum computers can work on many possibilities at the same time, which make them incredibly fast for certain type of problem. Okay, let me summarize what quantum computers are good at and what they are and not good at. What they do better, first, they are much faster at solving complex tasks, especially problems with lots of possibilities like breaking codes or finding the best route for deliveries. Okay, second, they can simulate nature. This means they can model how molecules and atoms behave, which is really useful for discovering new medicines. Third, they can provide high security through quantum encryption that cannot be hacked. Okay, but what they cannot do, they are not for daily tasks. Quantum computer will never replace your laptop for writing emails or watching videos. They also make many errors because qubits are very sensitive and lose their quantum state quickly. They are very unstable and they need extreme cooling like near absolute zero, which is colder than outer space, making them expensive and hard to maintain. Even though quantum computers are still new, they are already being used in several industries, such as drug discovery. Companies like AstraZeneca are working with IBM to test quantum methods for designing new medicines. They're hoping to cut drug development time by 20 to 30%. Okay. In finance, banks like JP Morgan, Chase, and Goldman Sachs are testing quantum for choosing investment and avoiding fraud or detecting fraud. In logistics, shipping companies like DHL are using quantum to find the best delivery routes. Ford, meanwhile, Ford use quantum to plan car production and cut planning time by 85%. Meanwhile, in energy, power companies are testing quantum for managing electricity grids with renewable energy like solar and wind. Okay, slide 7 should be pros and cons. Okay, here is a quick summary of pros and cons. The pros are much faster for certain problems, can simulate molecules naturally, solve complex optimization, can provide unbreakable encryption, and helps discover new drugs. Meanwhile, the cons are not suitable for daily tasks, high error rates, needs extreme cooling, hard to scale, and limited availability. Why? Because only big companies and research labs have access to quantum computers as of now. Okay. Next is challenges in adoption. This chart shows the biggest challenges companies face when trying to adopt quantum computing. According to the recent survey, 30 37% of companies say the biggest problem is lack of skilled workers. There just aren't enough people who understand quantum computing since very recent. Next is 34% say hardware limitation. The machines are still too error prone. Meanwhile, 25% say cost related issue. These machines are extremely expensive, mainly due to their materials and advanced cooling system. And 50% say lack of standards. The technology is so new that there aren't any clear rules yet regarding them. These challenges just show how hard it is to build and use quantum computers. Okay. Next is the analysis. This chart shows how quantum research has grown over time. In 2015, there were only about 700 research papers published. By 2025, that number jumped into over 4,200 papers per year. You can see the growth has been very fast, and especially after 2018. This shows that more and more researchers around the world are working on quantum computing, and the field is advancing very quickly, to be honest. Next is three waves of quantum computing adoption. Industry experts and researchers say quantum adoption will happen in three waves. Wave 1 is optimization application, happening now from 2025 to 2028. This includes things like route planning, factory scheduling, and investment choices. Wave 2 is simulation application from 2026 to 2029. This includes drug discovery, which is currently in development, and developing new chemical material. Wave 3 is advancing application from 2023 and no, sorry, from 2030 and onwards. This includes breaking and replacing current encryption and advanced AI. So we are still in the very early stage. To conclude, although quantum computing is new and has many flaws, it can still be improved over time, just like how normal computers were first developed. The researchers is currently coming up with a new way to solving the flaws of quantum computing, which is called as hybrid computing, which combine quantum computers with normal computers to get the best result. While fully reliable quantum computers are still years away, they are still improving and they are still proving useful for specific tasks current in the current days. The quantum future is coming, not overnight, but steadily. Okay, that's all from me. Thank you for listening. Good evening, good morning, good evening, and good night. Assalamu alaikum.